Hi. There are a lot of tools to check whether a series is convergent. Now, in this video, I would like to give you an introduction to the alternating series test. An alternating series is a series of which the terms are alternately positive and negative. The series that you see on the screen has this property. Notice the factor -1 to the power n plus 1 in the general term of this series. If n is odd, this factor is equal to 1. If n is even, it is equal to -1. So the first terms in this series look like this. I would like to check whether this series is convergent, and if it is convergent, try to determine the sum of this series. A series is convergent if the sequence of partial sums has a limit. Well, let's compute some of these partial sums and see what we get. The first partial sum is of course equal to 4. The second term in the series is negative, so the sum of the first two terms will be smaller than 4. In fact, the second partial sum is equal to 8/3, or 2.666. The third partial sum will be larger than 2.666, because the next term in the series is positive. However, its absolute value is smaller than that of the second term, so the third partial sum will still be smaller than 4. If we keep adding terms, we just repeat this procedure. First we subtract a number, and then we add a number with a smaller absolute value. Let's plot some of these partial sums in a diagram. Maybe we can see a pattern. The first partial sum is equal to 4. The second one is equal to 2.666. And the third partial sum is equal to 3.466. If we keep adding partial sums to this diagram, then we see that these points appear to converge to a certain value close to 3. Notice that the partial sums are greater than the sum of the series if n is odd, and that they are smaller whenever n is even. Okay? What is the sum of this series? If you would compute the sum of the first 1,000 terms, you would roughly obtain the value 3.14059. Now, the first 3 digits might remind you of a very famous real number, the number pi. The sum of this series is indeed equal to pi. Now, I won't explain why in this video, but if you know a thing or two about Taylor series, you might figure it out yourself. The value 3.14059 is thus an approximation of the number pi. But is it a good approximation? What is the approximation error? What is the difference between this value and the number pi? Well, let's take a look. Earlier on, we saw that the partial sums are greater than the sum of the series if n is odd, and that they are smaller whenever n is even. The value 3.14059 is partial sum number 1000, so this value must be smaller than pi. The next partial sum, number 1001, must be greater than pi. This means that the difference between the number pi and the approximation 3.14059 is smaller than the difference between partial sum number 1000 and partial sum number 1001. This difference is equal to 4/2001, or approximately 0.002. That's it for now. I hope you enjoyed this video. I hope you learned something, and I will see you in class.